Today we're writing ionic formulas. An ionic compound looks like this. Many charged positive cations stuck to many charged negative anions. So when we write the formula for an ionic compound, we are actually writing the lowest ratio of the positive to negative ions that makes up the entire structure of the compound. In this example, if the red spheres are fluorine ions and the yellow spheres are calcium ions, this compound has a formula of CaF2, because for every one calcium ion, there are two fluorine ions in the compound. Let's look at how to write the formulas based on the periodic table. Calcium is our cation, so we're going to write it on the left. Fluorine is our anion, so we're going to write it on the right side. Now if we look on the periodic table, we can find out what ion an element will make based on what group it's in. So group 1 makes +1 ion, group 2 makes +2 ion. Group 13 makes a +3 ion, group 14 makes a +4 or a -4 ion. Group 15 makes a -3 ion, 16 makes -2, 17 -1. Group 18 elements do not make ions. Now, the center section, the transition metals, will make a positive ion, but we don't know what, so they will tell us the number of the ion charge, but it will always be a positive. So calcium is right here on the periodic table, so that means the calcium will make a +2 ion, and then the fluorine is right here. So the fluorine will make a -1 ion. So we're going to put Ca +2 and F -1. Then the next step is to take the number from the ion charge, crisscross it over to the opposite side to become the subscript under the other ion. So this ion charge number goes over here to become the subscript under calcium. Then the plus and the minus symbols disappear. They do not appear in our final formula. So after we crisscross, we get Ca1F2. Now we have to bring that down to lowest ratio. We can't reduce this any further because it's already a 1 and a 2. So the final formula is CaF2. Now when we're writing chemical formulas, we never write the ones. If there's only one of them, we just write the symbol without the one. Okay, what if we are writing the formula for a compound made of magnesium and nitrogen? Again, the cation, the metal, is written on the left. The anion, the nonmetal, is written on the right. Now we look up on the periodic table. Magnesium, just like calcium, is in group 2, so it's a +2 ion. Nitrogen is in group 15, so it's a -3 ion. So we are going to write a +2 next to magnesium and a -3 next to nitrogen. The next step is to take the 2 from the magnesium, cross it over to become the subscript on the nitrogen. Ooh, that should be a 2. And then we're going to take the -3 from the nitrogen, cross it over to the magnesium, become the magnesium subscript. Then the plus and the minus symbols disappear. So now let's write what we have, Mg3N2. Now we look and see if we can reduce it down anymore. 3 and 2 can't reduce down. So our final formula, Mg3N2. Now if we take a look at aluminum and nitrogen. Aluminum in group 13 has a 3+ ion charge. Nitrogen, we know from the last problem, has a 3- ion charge. So here we have aluminum with a +3, nitrogen with -3. The 3 from the nitrogen crosses over to become the 3 underneath the aluminum. The 3 on the aluminum crosses over to become the 3 underneath the nitrogen. The plus and the minus symbols disappear. So now we have, Al3N3. Now let's take a look. We have 2 3s here. That means this is not at our lowest ratio. We can divide both of these by 3 to get 1 to 1. So we do that. We always bring them down to their lowest ratio. So ALN. Okay, we always divide. If both numbers in the formula can be divided by the same thing, we always divide to bring them down to the lowest ratio. Sometimes an ion is not a single element. Sometimes the ion is a group of elements that are bonded together, and we call those polyatomic ions. Now there are lists of common polyatomic ions. One common polyatomic ion that you'll see quite often is the polyatomic ion that's called sulfate. Sulfate is a sulfur and 4 oxygens bonded together, and they have gained 2 electrons to become a 2 negative ion. So we use this formula and crisscross the 2 negative when we're writing compound formulas with the sulfate. So if we are bonding this to a sodium, sodium is in group 1 on the periodic table, so it makes a 1+ ion. So we write 1+ at the top of sodium, and then the sulfate has its 2-. The 1 from the sodium crosses over to the sulfate. The 2 from the sulfate crosses over to the sodium. So we have Na with a 2, and then SO4 with a 1. Now we don't write the 1s, so that goes away, and you have Na2SO4. Now what if we had bonded to the SO4 was not a 1? Let's take a look at that. So we have SO4 again with a 2 minus charge. And it's going to bond with a boron. Boron is in group 13. So like aluminum, boron has a 3 plus charge. Okay, so the 3 on the boron goes over to the sulfate to become the sulfate subscript. The 2 on the sulfate goes over to the boron. The plus and the minus disappear. So we have B2SO4 3. Now if we left it like this, it would look like we have 43 oxygens, and we don't. We have 3 of the sulfate ions. So we have to separate the 4 from the 3. We do that by putting parentheses around the sulfate. So the rule is, anytime you cross a number to a polyatomic ion that's greater than 1, you have to put parentheses around the polyatomic ion's formula. Now, if you're just crossing a number to it that's just 1, it's going to disappear, so no parentheses are needed. So again, if the polyatomic ion gets crossed a number greater than 1, you put parentheses around it. So our formula is B2 parentheses SO4 parentheses 3. So this is telling us 2 borons bonded to 3 sulfates, SO4s.